Welcome to the future of understanding. This is NeuroMind Insights, where we unlock the power of your mind.
The caffeine in your morning coffee and the lethal micrograms of a synthetic opioid both interface with the same biological hardware inside your head. Your brain regulates consciousness by releasing neurotransmitters that bind to specific receptor sites. These molecules have precise geometric shapes that only activate their corresponding receptors, triggering the electrical pulses that dictate how you think and feel. To understand how drugs manipulate this system, we are mapping 36 different substances on this grid, the pharmacological matrix. We are categorizing everything from common stimulants to the deadliest chemicals on Earth by which specific receptor network they hack, and the exact margin between a high and a lethal dose. These compounds function by mimicking, blocking, or flooding the precise neurological pathways that already define your baseline existence. Stimulants override the brain's natural reward and fatigue limits. Normally, your brain recycles neurotransmitters through reuptake pumps, but stimulants block these pumps, trapping dopamine and adrenaline in the synaptic gap until the system is overwhelmed. Caffeine targets adenosine, the molecule your brain uses to track fatigue. By occupying those receptor sites, caffeine prevents you from sensing exhaustion until the compound breaks down and the day's accumulated tiredness hits all at once. Nicotine delivers a much faster surge of dopamine that burns out within minutes. This rapid depletion creates an artificial tension that trains the brain to associate peace exclusively with the brief window between cravings. Cocaine, derived from the coca leaf, forces a massive buildup of dopamine that creates temporary feelings of invincibility. However, the high is short-lived. Within minutes, dopamine levels crash, triggering severe anxiety and wild cardiovascular constriction. Methamphetamine and synthetic stimulants like methadone force neurons to dump their entire neurotransmitter supply at once. Over time, this scorched earth flood destroys the brain's ability to experience pleasure through natural pathways. Flocka, or alpha-PVP, induces a state of excited delirium where body temperature skyrockets. It removes the brain's internal governors, the signals that stop you from tearing a tendon or breaking a bone, allowing users to ignore catastrophic physical trauma. This energy is a metabolic loan, forcibly extracted from your future biological reserves. Depressants target GABA, the brain's primary braking system. By enhancing this chemical, these drugs slow the firing rate of neurons and suppress the central nervous system. Alcohol slows down the brain's internal communication network, creating a subjective sense of confidence while simultaneously destroying physical coordination and degrading liver function. Benzodiazepines force such a clinical sedation that the brain stops trying to regulate its own calm. Abruptly stopping their use causes the brakes to fail, leading to extreme neural overexcitation and potentially fatal seizures. Phenibut was developed in the 1960s to help Soviet cosmonauts stay calm under pressure without losing focus. It crosses the blood-brain barrier to provide a functional calm, but tolerance builds so quickly that the subsequent withdrawal is notoriously severe. GHB has a dangerously narrow therapeutic window. The margin between a social high and an immediate respiratory depressing coma is often just a single milliliter. Frequent GABA enhancement causes the brain to reduce its natural inhibitory response, leaving the user physically unable to stabilize neural activity without the drug. Dissociatives block glutamate at the NMDA receptors, effectively severing the connection between physical sensory input and the brain's processing center. High doses of ketamine induce the K-hole, where perception detaches from the physical body. This detachment masks significant physical risks, including long-term bladder damage caused by heavy use. Nitrous oxide provides a brief high by starving the brain of oxygen. Repeated use depletes vitamin B12, leading to permanent nerve damage. In high doses, DXM in cough syrup converts into a potent dissociative called DXO, causing total motor loss and mechanical movements known as robotripping. PCP creates such extreme sensory severance that the brain cannot register pain. Users may push their bodies through mechanical breaking points without realizing they are being injured. These substances demonstrate that perception requires a continuous exchange of glutamate-mediated signals. Disrupting this transmission leaves the mind drifting without physical context. Psychedelics primarily interact with 5-HT2A receptors, creating new neural pathways between distant sectors of the brain that normally do not interact. Cannabis targets the endocannabinoid system, mimicking natural anandamides to distort time and sharpen senses, though it frequently triggers paranoia at higher doses. MDMA forces a flood of serotonin to create connection, while LSD triggers identity shifts and sensory blending at microscopic concentrations. Psilocybin dissolves mental boundaries for deep psychological insight. By contrast, the synthetic 2CB creates intense visual distortions while leaving the user's headspace relatively clear. 25I-NBOMA is a toxic synthetic often sold as fake acid. It overstimulates receptors to cause fatal blood vessel constriction and seizures from a single dose. Ibogaine's intense multi-receptor mechanism induces a 24-hour psychological review used for opioid detox, despite its high cardiotoxic risks. Inhaling the vapor of 5-MeO-DMT, derived from the Sonoran desert toad, triggers instantaneous ego death, erasing memory and awareness in seconds. Dipit is a pharmacological anomaly that exclusively distorts auditory processing. It drops the pitch of every sound you hear, making voices sound demonic, while leaving visual perception entirely intact. Serotonergic activity suspends the evolutionary filters that keep baseline reality stable, allowing a raw, unfiltered stream of neural data. This category includes mu-opioid agonists that flood the brain with feelings of safety and deliriants that block memory and reality. While heroin and fentanyl lead to brutal withdrawal cycles, kratom acts as an atypical opioid that provides stimulation at low doses and real opioid dependence at higher ones. Dizorphamine, or crocodile, contains caustic chemicals that cause the user's flesh to necrotize and rot while they are still alive. Atorphine, or M99, is roughly 3,000 times stronger than morphine. Designed to sedate elephants, a dose the size of a grain of salt will cause immediate respiratory arrest in a human, even through skin contact. During the 2002 Moscow theater hostage crisis, Russian forces used a carfentanil-based gas to end the siege. The potency led to the death of over 100 hostages, highlighting the thin margin between sedation and death. Salvia provides no euphoria. Instead, it interacts with kappa opioid receptors to terrifyingly replace your entire reality for several minutes. By blocking acetylcholine, scopolamine erases free will and memory formation. Datura functions similarly, trapping users in waking nightmares for days that are impossible to distinguish from reality. These compounds demonstrate that pain, autonomy, and the ability to recognize reality depend entirely on the presence of specific molecular messengers. Instead of interacting with receptors, some of these chemical substances bypass them entirely and operate purely as metabolic toxins. DNP originated as an industrial chemical in World War I munitions factories. It uncouples oxidative phosphorylation, forcing the body to convert energy directly into heat and cooking the user from the inside out. Consuming massive quantities of nutmeg introduces myristicin into the system, causing organ damage and up to 48 hours of frightening delirium. GenChem involved inhaling the gases from fermented human waste. This results in a brief hallucination driven by a sudden lack of oxygen to the brain. Adrenochrome is oxidized adrenon. Despite internet conspiracy theories, it is a chemically mundane substance with no established psychedelic effects. For these metabolic outliers, the subjective experience of a high represents the brain's internal monitoring of its own biological collapse. These 36 chemicals are vastly different, yet they all operate within the same rigid biological framework. Homeostasis demands equilibrium. Every chemically induced peak must eventually be paid for with an equal and opposite physiological trough. Toxicity is defined by receptor affinity and the margin between an active and lethal dose, regardless of a drug's legal status. Consciousness persists as a fragile chemical equilibrium. Introducing foreign molecules into this environment alters the user's fundamental perception of existence.
Thank you for watching. If you enjoyed this video, please like, comment, share, and subscribe to NeuroMind Insights for more.